Filming now.
Good morning, Year 12. So this first prac that I'm filming today is what we're doing. I haven't numbered it yet, but it's determining the concentration of a solution via titration. So what we're doing is we're taking KHP, which we made a standard solution of, and I've calculated that solution, and I know it to 3 significant figures because I weighed the KHP to 3 significant figures. I've calculated that out, and in this case for the one that I have here, sorry, its concentration is 0.102 moles per litre, and I know those 3 significant figures. We're reacting it with sodium hydroxide, which we don't know the concentration of. This is our unknown that we're trying to determine the concentration to 3 significant figures. And it's a neutralization reaction, so we're producing water and then the conjugate base with that acid. So we need to talk about how we're going to set up this titration and how we're going to prepare the glassware as we're going through. So the first thing that I notice is we've got a weak acid, and I want to do a titration. I want to find out this strong base. So weak acid, strong base is going to give me an endpoint that's above 7. Because the conjugate acid here will produce hydroxides in solution. So the pH is going to be above 7. So the right indicator that I need for that is going to be phenolphthalein, good old clear to pink, okay? And remember, it's clear below about pH 8 and it's pink above pH 8. The best endpoint that I want to see is clear to pink, okay? So when I put my flask down here, I want, underneath the burette, I want it to start off clear, and as I'm adding the base, I want it to go to pink. So therefore, acid in here in this case, base in the burette, okay? I know a lot of places say always put your unknown in your burette, but that's not always going to give you the best endpoint. So for today, our base is going to go in here, and our acid's going to go in here to give us the best endpoint. Let's start with preparing the burette, okay? First, of course, you're going to have to use distilled water. I've got my distilled water here. A couple of rinses with that. So, tap closed, going across. Just put a little bit in. That's probably a lot, but that's okay. And we need to make sure that the water is going all the way to the bottom and you're rinsing it all the way to the top there. Let some through the tap. You can let it all through the tap, but it takes a while. You can always tip it upside down. So we want to do that twice. The method for this is we want to get rid of anything that's been in this burette before we've used it to make sure it's not going to change our reaction at all, possibly interfere with it. We don't know. All right, rinse the tap a little bit. That's enough, and I'll tip the last out there. Okay. Now I know I need to put the base in there, sodium hydroxide, and that's what I'm trying to find the concentration of. I've got it here in my beaker already. It's about 0.1 moles per litre, but we're going to determine it to 3 significant figures. If I put it in this, the trouble is that the water that's already is in it is going to change the concentration of this. It's going to dilute it. So I somehow need to get rid of this water. And the best method for doing that is to actually rinse this burette with the solution that I'm putting in there. So I need to rinse it with the sodium hydroxide solution. Close the tap, pour a little bit in, just down the bottom. Okay, and I want to swirl it around. Something that I'm thinking of though, safety. Sodium hydroxide reacts with oils on the skin, it saponifies them, makes them all soapy. I don't want too strong sodium hydroxide on my skin, but I know I've got reasonably about 0.1 moles per litre. I'm not too worried in this instance by putting my finger on the top. But if you are, gloves is the word that I'm looking for. Wear gloves. But I'm not too worried. 0.1 mole per litre. It might feel a touch soapy to the skin, but other than that, it's all good, and I'll wash my hands after I'm done too. Okay, so this is the sodium hydroxide solution. It's all good going down the sink too, it's very dilute. I'll make sure I run some water through there when I'm done. I'll give 2 rinses of that as well. I know this seems a little bit tedious, but there's reasons why we do it. All right. Once I've prepared it, I can put the sodium hydroxide in there ready to deliver into my conical flask by titration. And remember, I want to fill it near the top, but I do not want to waste any time at all trying to get it to 0.00. It's not worth your time and effort. And remember what I say, if I see that on your sheet one time, I'll just presume it's a coincidence. But if I see it on your sheet more than once, I'm going to assume that you've been wasting your own time and probably mark you down for that. You just need to get it somewhere near the top. It doesn't matter where. All right. If you ever go over the 0 though, let some out of the tap. Okay, I'll put this on my clamp. I'll turn it around. The tap's closed. Should I read it now? Why not? Remember, bottom of the meniscus. I'll turn it around once I've read it. All right. And remember, we're measuring it to 2 decimal places, where the second decimal place is either a 0 or 5. 0 if it's on the line, 5 if it's in between. All right, I've got my reading there as 1.15 mil. Let's see how the camera does. I might put a white sheet behind it. It's a bit wobbly too. I don't know if me stabilizing it is going to help.
Yeah, no, that's good.
Cool, thanks Mr. Galliner. What did I say? 1.15 mil. Okay, so my start position for titration 1.15 mil. Okay, if it had been right on the 1.1, I would have put 1.10, but it was slightly below that line, so I'll put a 5. Okay? All right, now I need to prepare my flask for the acid. I'm going to do I might as well do all 4 of them at the same time. Do a little production line. Okay, I need to deliver 25 mil of my acid into each of those. Actually, I might only do 3 because I've just thought I've only made up 100 mil and I need some volume to rinse my glassware with. If I have 4 lots of 25, I've got no volume to rinse my glassware with. I'm limited to 3 titrations in this instance because of my volume that I've made up, but that's okay. All right, I'm going to rinse them with water, of course. 2 rinses with water, give them a good swirl. And then I need to think about what I'm putting in there. I'm putting in a certain concentration to a known volume, so I'm really delivering a number of moles to these vessels, okay? So the fact that it's got a bit of water in there does not matter, because I'm delivering not a certain concentration, not a certain volume, but I'm delivering a certain number of moles. So even if I have a little bit of water left in there, it's okay, because it's not going to change the number of moles of acid that I'm putting in there. So for these guys, the flask that I'm doing underneath, that is receiving those, because I'm delivering a set number of moles, rinsing is just twice with distilled water. Do all 3 at the same time. Okay, now, as I was just saying about the acid, our KHP solution, did I already do that twice? That's okay, I'll do it 3 times. KHP solution, I need 25 mil, so I've got a 25 mil bulb pipette. I need to prepare that, okay? So like everything, twice with water. With the bulb pipette, you need to put in enough volume to get some in the bowl. Put your finger on the end, get it up into the bulb, make sure it's all swirling around, get it right up to the top. Swirl it around, then let it drain through. Do that twice. Now, I'm going to deliver a certain volume in here, 25 mil. And the pipette's been calibrated to that, to the calibration line, which is very hard to see, but it's up, right up there, very faint. If I have some water left in there, it's not going to be 25 mil of my acid. It's going to be less because I'm going to dilute it. So this is like the burette. I want to rinse it with the solution that I'm delivering in there to make sure it's getting as close as I can to the actual concentration that it is there. But once I deliver that 25 mil into there, it doesn't matter because it's a known number of moles. Okay, a little beaker? I'll just grab a little beaker. And I'll just get a pipette bowl. How professional. Where have they gone? Oh, the pipette bowl. Oh, they're already there, aren't they? And I thought I was ready. What an amateur. Alright. So this little beaker that I'm going to put some KHP solution in, because I don't want to pipette straight out of my stock bottle there, because I don't want to contaminate it, even though I'm using it all in this instance. Twice with water, and I don't want to dilute it, so I'm going to rinse it with the solution that I'm putting in there. A little bit in the bottom, let it glug glug. It's only low concentration and I can spill it about a bit. Oh, I better label this. Lots of clear solutions to keep track of. KHP. Good. Ow, stabbed myself. Alright, now I can put some KHP in. I want a fair amount. Okay, I haven't rinsed the pipette with the KHP yet. So I need to draw a little amount of that in. Remember when you're adding the pipette filler to the pipette to hold the pipette up the end, not down here, because that is likely to snap it. Up the end, put it on. I want to draw a little bit up into the bulb. Oh, I left it above, that's okay. Not too professional, but that's okay. And again, I want to rinse all the way to the top. Get rid of as much water as I can. I'll do that twice. No, it's not making for the most interesting video, but it's making for the best chemistry that I can do right now. A little bit in there. Now this is the KHP solution, remember? So I've rinsed this 4 times. That's okay. Gotta be patient when doing chemistry. Okay, now I'm ready to actually put 25 ml in there. Alright. Add it on. What I'm going to do is draw it above my calibration line. Because the trouble is, I'll show you what happens if I try to get the calibration line. If you ever reach the end and haven't got the full volume, put your finger on the end, push it back down, put it back on, start. Okay, I'll try to get it to the calibration line. Okay, there it's pretty close. But do you notice it's losing a bit of pressure? I can't guarantee that when I pull it out and deliver it that it's going to be there. So what I need to do is pull it above and change to my finger. My finger holds the pressure. And then what I'm going to do, lift the beaker, make sure there's glass to glass contact with the beaker and let it drain back by rolling my finger slightly until I hit the calibration line. It's a much better seal, much more accurate, and I can guarantee that I'm giving 25.0 ml. There we go. Deliver it to my first one. Got a bit of water in, that's okay. I know I'm delivering a certain number of moles of KHP here. I'm gonna leave it at an angle. The glass, trying to get it into position where you can see, there we go, that's a bit better. The glass is touching glass. The glass is drawing down the liquid from there by capillary action. And there will be a touch left in the tip, but the pipette is designed to counter for that volume. Okay, so once it looks like it's finished, I'm going to count to about 5. I'll just blab on a little bit more, and then I can take it away. And then I can guarantee I've given the 25.0 ml. That's about enough, okay. I don't need to rinse again, that's the good news. I need to do that again, and I need to do it to get all these 3 beakers. So just a little bit of patience. So drawing it up, getting it above that calibration line, bringing it up to eye level. So I brought it way up there, get my finger on it, up to eye level. Don't ever kneel down to look. You don't know what's on the lab floor. There could be broken glass, there could be anything that you're putting your knees on, not very safe. You're also putting your head right at bench level, ready for stuff to spill right in your face. Not a good idea. There's 25 mil. Leaving it to drain. It's hard to do it and also show. There we go. Always tend to do chemistry at eye level. Lift things up, never lean down. It's much more dangerous to kneel, don't know what's on the floor, and also if something spills, it's going to spill right in your face. Okay, it's going down. It's near the tip. There we go. A couple more seconds and I can guarantee that I've got that 25.0 mil in there. All right. One more to do. Top up the volume. What's that song? Pump up the volume? I don't know.
No idea.
All right, one more to do. The next step that we're going to do after that is put our indicator in them. Now, because we've got acid in them and we're putting phenolphthalein in there, I sure hope that it looks clear. You know you've got a problem if you think you've got an acid in there and it turns pink. That's saying you've got a base in there above pH 8. One of the most common mistakes that I see in assessment tasks is people not labeling their glassware and not distinguishing between what the acid and base is. And so they get to a problem where they've done a titration and they've gone through 50 ml and they've seen no color change. And it's quite easy to tell what they've got in each by using phenolphthalein or an indicator, and it quite often turns out that they've got both in the flask and the burette, they've got the same thing, like they're titrating an acid with an acid. That's not going to work. Or they're titrating a base with a base, and they get to a point where they're like, nothing's happening, there must be something wrong. Usually is. They're adding an acid to an acid. One of the most common problems. If you're ever not too sure, just a drop of phenolphthalein will tell you, have you got an acid or a base there? If you've got a base, it'll turn pink. Letting this last one drain down, and then we'll add our indicator in. Then we need some white paper underneath here because we're looking for that slight pink endpoint. What else do we need to do? We've got our start volume. I think we'll be all set after that. All right, count a couple more seconds. Okay, there's my 25 mil. And phenolphthalein indicator, because we're going to have a slightly basic endpoint. That's good, it's nice and clear. 2 or 3 drops is the best estimate with phenolphthalein. It's nice bright endpoint. Some other indicators you may need a little bit more, but you want to limit it. Okay, I've labeled these number 1, number 2, number 3. Don't know if you can see it there, it's hard to see in the green texture.
Yeah.
But that's okay. So I'll put number 1, it just helps me keep track. You know what I did? Oh no, it is good. Okay, put it underneath. I'm just going to lower it slightly. You really want to ensure that all the liquid, you don't want to do that, but you want to ensure all the liquid that comes out is actually going into your flask. Okay, I'm right-handed. So what I'm going to do is left hand controls the tap, right hand does the swirling. Now the first titration, I'm going to do a rough titration. I'm going to run through there pretty fast. But I kind of already got a hint. I know my KHP is 0.1 mol per litre, and I know roughly my sodium hydroxide is 0.1 mol per litre. So the equivalence point should be about the equal volume of what we put in there. So it should be about 25 mil. So I've already got kind of a preview of what's happening. All right, get a nice steady stream. After a bit of time, you might notice a little bit of pink going in there. And what you're looking for is that pink and how long it sticks around. Notice it doesn't stick around long if I give it a stir. Once I'm getting towards the end point, it'll start sticking around a bit longer and getting harder and harder to stir out. I'm looking at my level. I'm getting closer and closer. You can add it drop by drop, but I'm getting, see how it's sticking around there longer? Oh, I'm very close. I need to add drop by drop. This is meant to be a rough one, but I'm doing it a bit. Okay. That was literally 1 or 2 drops more, and I've hit my light pink endpoint. Okay? Now I'm going to read off the volume, and what I might do is show you what happens when you overshoot that endpoint. So let's read off the true volume. Okay, it's down here. And I'm reading at my side, and I'll turn it around. It's it's just before 30, so it's 29. That's 3 off, so it's 29.70. 29.70. It's right on the line. I'll turn it around, and I might lower it a bit so you can see the 29 before it. Put a bit of white paper behind it. Yep. All right. I'll show you. I'll just add a bit more base there. I'll show you how pink it goes if you overshoot it. See the difference? You've gone too far. That lightest pink is your best endpoint, okay? All right. I'm ready to start the second one. I know I'm gonna need roughly about 28 mil. I need to top this up. All right, I didn't use a funnel, but that's okay. And I'm topping it up with sodium hydroxide. Make sure you get the sodium hydroxide. Don't top it up with your acid and get a neutralization reaction in your burette. That would be very hilarious to a chemist. The funniest thing they've heard all day, probably. And you know how funny we are. Cracking myself up. All right, notice I didn't waste time trying to get it at 0.00.
Oh, do you want to show here first?
Yep, have a look at the volume. Oh, it's a bit wobbly. All right, I'm going to turn it around and read it. So it's between the 1 and the 2. It's just below the 1.5. It is 1.65 because it's not right on the 1.70. So it's 1.65. Put it in my titration 2 for the start. I'll keep these in the same order. Number 2. I've got my indicator in there. Don't forget to do that. All right, I'm ready to roll. Okay, zipping down quickly. I know it's going to be roughly about 28, 29. So I'm slowing down as I'm getting down towards there. Drop by drop. So I'm about 27. Sticking around a bit longer. Notice I just turned it off. It's still going away. I'm doing it drop by drop. Maybe that's a bit too slow. No, it's getting there. All right. Oh, look at that. Just very touch of pink. That's a really good endpoint. I like that one. Okay, notice I took that one too far, but it's lighter than even the first one, but it's definitely not white. It's definitely not white. It's definitely not clear, so I'm seeing the light. All right, I'll read my final volume. 29.75, I reckon. What do you reckon? You concur?
Yep.
Yep. All right. Really good. Just a touch of pink in there. All right, I'm gonna have to top up the sodium hydroxide to do my third and final one. Now remember the number, ideally, that we do, one of the most common questions, how many titrations do I do? The rule that we go for is you must have 3 concurrent titrations, where the final volume is all within 0.2 milliliters of each other. Now we haven't got that choice today because I didn't prepare enough KHP solution. And maybe an assessment task, I'll just stick to 3. But ideally in the real world, we want 3 concurrent titrations. Okay, do you want to zoom in on that first volume? I'll try to stabilize it. It's between the 0 and the 1, and I'll turn it around and read it a bit better. Okay. It's below the 0.5. It's right on the 0.6. So it's 0.60 because it's right on that 0.6 line. All right, I've got my third one. It's got indicator in it. I'm ready to roll. Zip down really quickly. Slowing it down. Notice it still disappeared. If I've gone too far, I've ruined it. Okay, going drop by drop. Got a little bit of time. So you get those little pink splotches, but they quickly disappear. No, not there yet. A couple more drops. Getting really close, aren't I? They're sticking around longer and longer. Oh, look at that. There we go. Just a touch of pink. Okay, I'll read off my volume. It's between 28 and 29. It's over halfway. It's 28.60 by my reading. What I might do is just quickly put these in my calculator because I haven't got much mathematical brains today, and just make sure and get our final volumes. This will be the point where you decide, do I need to do a 4th titration or more? But let's see how we go. 29.7 minus 1.15, 28.55 mil. Oh, don't put my units in a table. 29.75 minus 1.65, 28.10. Remember, even though the calculator says 28.1, you know this number is 5 minus 5, which equals 0. Don't leave that second decimal place out. Don't always blindly believe your calculator. 28.60 minus 0.60. Look at that, calculator only gives me 28, but I know that that's a 0, and I know that that's a 0. Okay, how are we looking? Oh, we're not looking too great because the most extreme difference that I've got there is 0.5 mil. I would need to do a 3rd one. These ones are within 0.2 mils of each other. They're really good, and hopefully that one, if we do it, will turn out to be within 0.2 mils there. Then we could use those 3, all the values actually, but that. Maybe I went a bit too quick on that first titration. Okay, doing our calculations, what we need to do is, I'm just trying to work out where we should do it, add some more information in. We've now can work out an average titration volume of our sodium hydroxide. So it's the average between those 3 numbers. We can't eliminate the first one. I've got to use it, it's a valid piece of data. So add them together and divide by 3, because I've got 3 values. Divide it by 3, and I get 28.216 repeater milliliters. I don't need a round now, I only need a round at the end, so I'm trying to put as much significant figures in there. I'm hoping to get 3 significant figures at the end, so I need at least 3 there, a little bit more. Okay. We've got our volume of our sodium hydroxide from the burette. The volume of KHP we added 25.0 milliliters all the time. That's how much we put into these at the start. Okay, so we can work out our moles of KHP that we had. It's going to equal our concentration times our volume. Mole per litre times it by our volume to make sure that the litres cancel out. So this needs to be changed into litres, 0.0250. Don't drop the significant figure there. Put it in my calculator and I'll know how many moles of KHP we had. 2.55 times 10 to the negative 3 moles. Okay, so let's look at our stoichiometry now and work out how many moles we had of sodium hydroxide at the equivalence point, okay? There must have been, because it's a 1-to-1 stoichiometric ratio, there must have been the same number of moles at that, what we saw, the endpoint or the equivalence point. So we know the moles of sodium hydroxide equals the same, 2.55 times 10 to the negative 3 moles. Okay, we're looking for our concentration. We've got our moles, we've got our volume, we just need to divide them. So a concentration of sodium hydroxide equals our number of moles up the top, divided by the average volume that we calculated in litres, because moles per litre, 0.028216 repeater litres. And that will give me my answer. Well, an answer, 2.55 times 10 to the negative 3 divided by 0.02821. Put a whole heap of 6's in. Oh, I didn't like that. The calculator just went dead. I'll just grab a calculator. Oh, the door's locked.
You've got you go on.
What a time for a calculator to go dead, hey? Oh, you got one on the phone. Calculator just went dead in the middle of the video. Yeah. Alright, got the Crayola calculator. A nice little simple kiddies one. It'll do, oh I can't do, oh that's okay. I'm gonna have to convert my 2.55 times 10 to the 3 is 0.00255 and divided by 0.028216. Oh, that's all I can put in. That's okay. Okay. 0.0884753 moles per litre. That's not our final answer though. Let's check our significant figures. 3, 3. Well, we can only report that to 3 anyway. Or we can report that to 4 actually. So we're limited by the least number, which is 3. So we can report this to 3 significant figures. Coming in from the left, that's number 1, that's number 2, that's number 3. Number 4 is larger than 5, so we need to round number 3 up. So it actually equals 0.08885. That's not a good 8 moles per litre. We know that for sure. Is it near our 0.1 that we assumed it was? It's reasonably close, but let's not pick on Mrs. Dennison. All right. Safety-wise, all this is very dilute. Acid base can go down the sink. Thank you for your time, everyone.